100 BCE, it was discovered that combining copper with a newly discovered element called tin improved the quality of weapons and tools, kickstarting the Bronze Age. The discovery of tin helped catalyze thousands of years worth of new innovations, including an item that you may be using to watch this video, your smartphone. But where does tin come from? The story of tin begins billions of years before its discovery. Tin formation in our universe can be attributed to two processes: the death of small stars, or when two neutron stars, the dense leftover cores of large dead stars, merge together. The neutron-dense environment of these two processes allow for neutron capture to take place, where existing elements capture nearby free neutrons. As an element accumulates neutrons, it becomes increasingly unstable, so to gain stability back, the element will undergo beta-minus decay to transform a neutron into a proton. With the addition of an extra proton, a brand new element is formed. This process is repeated, and more elements are created, like tin. Now the question is, how did tin get to Earth? Billions of years ago, our solar system looked something like this. It was a solar nebula, a cloud of microscopic dead star matter and gas. Our nebula was compressed under the intense gravitational pressure from a nearby supernova shockwave, forming a flat rotating disk, like the one seen here. Eventually, this matter, some of which contained tin, condensed and combined to create the Earth and the other planets. Okay, so we know that tin can be found on Earth, but where on Earth? The layers of our Earth began forming 4.56 billion years ago when heavy molten phase iron and elements that like to form bonds with iron sank to the center of our Earth, creating our core. This did not include tin. Instead, tin stayed near the surface since it likes to form bonds with oxygen and silicon, making it a lithophilic or rock-loving element. Later, the Earth's crust formed from the partial melting and cooling of incompatible elements, such as tin. An element is considered incompatible when they are unable to substitute the magnesium 2 ions or iron 2 ions in olivine, one of the most common minerals in the mantle. This is because the chemical properties differ too much from magnesium or iron. For tin, tin 2's ionic radius is too big, and for tin 4, the charge is too big. So far, we've learned how tin became incorporated into our Earth. Now it's time we learn how we incorporate tin into our lives. Most of the tin used in modern-day products is from cassiterite, the most mined mineral containing tin. Cassiterite is mined in many places in the world, such as in China, Bolivia, Nigeria, Southeastern Asia, and the United Kingdom. One example of a major mineral deposit is the Huanggangliang iron tin deposit located in northern China. Here, cassiterite can mostly be found in granite and in other igneous rocks. Two popular methods to mine cassiterite include bucket line dredging, where deposits are excavated from the seafloor and brought to the surface using a continuous conveyor belt of buckets, and hydraulic mining, which uses high-pressure jets of water to dislodge deposits. Smelting is a common method to extract tin, which involves heating cassiterite to 2500 degrees Fahrenheit in a furnace containing carbon. Afterwards, the extracted tin is purified by one or multiple methods: washing it in an acid or water-based solution, aka leaching, electrostatic separation, or magnetic separation. As mentioned earlier, smartphones contain tin. Tin is a major component of the ITO layer of touchscreens. This conductive and translucent layer is used to help relay what you tap on your touchscreen to the inside of your phone. Tin is also used in the circuit board soldiers of phones, which act as the glue of phones, relaying signals from the electrical components to the circuit board. Though tin mining is important, environmental degradation and human rights abuse often arise from this process. This abuse is notably seen on the island of Bangka in Indonesia, where hundreds of tin miners, including children, have been injured or died in recent decades. Here are excerpts from Kate Hodl's 2012 article in The Guardian regarding this mining. Feel free to pause the video. With new technological advancements, the demand for tin will persist. Therefore, it is important to acknowledge the environmental damage and inhumane treatment of workers who mine tin and other metals across the world. Through educating others, advocating for the humane treatment of mine workers, putting an end to child labor, protecting the environment, and holding tech giants like Samsung and Apple accountable, we can ensure that the story of tin continues in a more sustainable and resilient manner. Thank you.